Hello guys, in this video, I'm going to explain the time value of money. So the time value of money discuss about how the value of money changes in a certain period. So let's say, for example, how much your allowance 10 years ago. So in this case, 10 years ago, you can afford many cakes, many pieces, many toys since you're elementary school, let's say. But in the point of view in the present position, maybe you can afford only a little bit piece of cake or maybe just a game toys, since the value itself changed but the number still constant, still the same. So if you want to buy something right now, how much candy you have? Maybe only just a pieces, only a little amount of candy. So there are the difference between the value of money and the sum of money. The sum of money will stay the same at the end of the time, but the value itself will change due to many aspects. So there is such important terms such as time. Time is the important elements in decision making. So let's say that a dollar in hand today is worth more than a dollar in hand tomorrow. Why? Because I could invest and gain profit tomorrow. I could avoid loss due to inflation. So our money right now is more valuable than any money that will occur in the future or losing something yesterday or in the past times. So amount of money that you own right now is more important than any money or others money you have. So the time value money is changing as the time goes by. Why it happens? Because there are so many aspects, just like inflations, and the time value of money is measured in terms of interest rate. The value of money doesn't equal with math expressions because the value of money is just like a bank interest rate, whereas the sum of money is a math concept, just like 1 plus 1 equals to 2. But if we talk about the time value of money, 1 plus 1 is not equal with 2. It will change. And also, if you talk about the value of money, it will also talk about cost and benefit that will evolve at different times because it causes the different the value of money. And the method to comfort the position of the money itself, change it to the point of view. In a certain point of view, let's say it is equivalence. So equivalent is a method to estimate the equity value of money for different times. Okay, for example, we need to understand the interest. So the interest will be discussed in the next slide. Assuming that my mother wants to save 5 million in 2014 at a commercial bank. After 1 year later, the saving has risen up to blah, 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 something. So to calculate the ending balance will be 5 million, add with 5 million multiplied by the interest applied by the commercial banks. So the ending balance will change. It's not the same with the initial amount that we deposit. It will be higher than initial amount. So the addition itself is interest. So interest is the amount of money paid as the use of loan. And it's a compensation as the decrease of the value of money during the long period. And then interest to ensure the value of money stay the same. And whether you want to borrow some money or you want to deposit the money, it will be charged by interest. Okay, so the ending balance of your debt or the ending balance of your deposit will will change. It's not stay the same as initial amount. And to calculate the interest, let's say the present amount on subtract with original investment. So why there is a loan? Because there are some explanation and answer to answer. There are some answer uh, toward the questions, because there needs to be returns. There is to be return because our money today, our money that own today is more valuable, you know. So there are needs to be written quickly. There needs to be written immediately, yeah, versus tomorrow or versus in the future. So as a compensations, that money could not be paid, could not be paid immediately. That compensation converted into some fee, let's say some fee or some charge. So that's the interest. And then the second explanation will be the loss of value from other potential use that must be recognized, because somehow the let's say the people who borrows the money, there is a possibility, there is possible that people will not pay, okay, will not pay due to some financial issue or many factors around the people who cannot pay pay the bills or pay the debt. So that compensation itself, the risk compensation, will be charged also. We will charge to the interest concept. So that's the answer why there is interest on a loan. And there are four relevant variables in dealing with the time value of money. So you have to understand this relevant variable. The first variable will be principal amount. The principal amount is the initial amount that you give, that you had when you borrow the money. And then the time period of the loan, the interest rate, and the time period to which the interest rate applies. So this is the important things, because you have to know when your interest will be compounded, will be double or maybe multiple times higher than the initial amount. And then there's a formula to estimate or to calculate the rate of interest. The rate of interest is found by the interest at interval time divided by the principal amount multiplied by 100%. For example, a student borrowed some money, 15 million rupiah in 2011. At the end of 2014, his debt recorded 80 million rupiah. How much the accumulated interest he must pay? Then to calculate the rate of interest, we must know the interest at interval time. So we calculate the interest first, and after that, we divide it by the principal amount, which is 15 million. So the first step is find out the interest, total interest gained by the subtracting the ending balance. Let's say this is the observations. We take the observation at 2014, 18 million minus 15. So we get the total interest at 3 years, starting by 2011 to 2014 is 3 years. So 3 million is for 3 years. So each year, the total interest rate is 1 million. So the rate of interest is expressed by annually, expressed annually or by years. So we have to divide the interest with year. So a million, which is in annual system, divided by 15 million, then is principal amount, multiply by 100%. So we want to know the percentage of rate of interest applied in this bank, commercial bank. And the rate of interest equals to 6.67%. So make sure you have to look carefully the total interest rate applied and also converted into annual. There are two types of interest, the simple interest and the compound interest. And the difference between the simple interest and compound interest are located to the look at it to the system itself. The simple interest is applied to the initial amount, but the compound interest is being applied by the former balance, or the former balance, or the former initial amount. Let's take a look at the examples. Let's say I borrow some money. I borrow some money, 200,000, and I want to. If I pay the debt the second year, or the third year, or the fourth year, I will illustrate by this table. Okay, the first thing you have to do, you just draw the table and then put the right information, just like your initial amount or beginning balance, and also the rate of interest that applied, and also the ending balance. Okay, and then if I pay the debt at the end of the year, the amount of money that I should pay is 210. 10,000 is gained by multiplying the rate of interest by the initial amount or principal amount or beginning balance, which is 10. 5% times 200,000 equals to 10,000. So the ending balance, just the additions of the beginning balance with the interest, which is 210. Now, if I cannot pay at the end of the first year, and I'm willing to pay at the second years, the ending balance will be different because the interest will get double. The simple interest, the total interest at the second years is stay the same and remain the same since we applied the simple interest. So 5% times 200,000, which is 10, and the ending balance will be 210 plus 10, which is gained by the second total interest, 220. And repeat the same actions, repeat the same step until year 4. So the total interest is 40,000. If I pay the bill, if I pay the debt at the 4 years, it will be 240,000, and the accumulations of the interest is 40,000. So that's the simple interest. Now we can skip all the manual step into the quick formula, which is IPIN. I can summarize the formula just like IPIN. Interest equal to PIN, which is IPIN. P represent the principal amount, I represent the interest rate, and N represent the number of interest periods. So to calculate the total interest is 5% times 200,000 times 4, which is 40,000. So you can save your time in calculating the total interest, right? Now, to find out the right amount that should be paid, or you can apply it as a deposit system, the ending balance of your investment is principal amount interest rate, which is the formula is PIN. P principal amount, number, total amount, and the total ending balance, or the total that should be paid, is 200,000 plus 5% times 200,000 times 4, which is 240. So this is the same number as the manual step, right? Now, let's take a look at another type, compound interest. So the compound interest is different because the interest rate will be applied to ending balance, not the beginning balance. Okay. So let's say if you want to pay your bills, your debts at the second years will be totally different with your initial year. In the initial year or the first year, the ending balance will be the same as the simple interest. But the second year and the upcoming years will be totally different since the interest rate applied at the previous ending balance. Okay, now let's take a look, especially in the second years. So the ending balance will be 210 plus 10.5. Okay, 10.5 gained by this calculation, 5% times 210. 210 is produced by the former calculation, which is the ending balance, not to the beginning balance. And repeat the same calculations, and it will get then it can be assumed that using the compound interest will get a higher total interest compared to the simple interest. And for your information, that compound interest is widely used in many systems and many countries, still apply this kind of calculations. So I will talk mostly the compound interest in the upcoming meeting. So you know that the equivalence is a method in converting the value of money. You know, the value is what you get, it's not what you pay. What you pay is not equal with what you pay. What you pay is not equal what you get. So in this case, the equivalence is converting amount of money into a certain period. So let's say 1,000 as per today is totally different with 10 years ago. 1,000 that in past will make many purchase, just like buying something, like material, a lot of material, a lot of products. But as per today, maybe I just can afford small pieces of product. So now the compound interest, the equivalence of compound interest is quite interesting because the compound interest itself, maybe we can summarize as three. Yeah, we can summarize as three different compound interests: single payment, cash flow annual, and cash flow grading. And for single payment, it's divided by future towards present and present towards future. For single payment, let's say there are some relationship between the future and also the present. It means you want to know the future value if the present value is already mentioned, is already known. So this is the manual formula. But you can skip the calculations, the traditional calculation, into quick formula. And to memorize it, I will use some symbolic that two alphabet that come first will be repeatedly followed by the same alphabet, which is, if you want to know the future value of present, the compound factor will be FP as well. So the FP IN can be found in the table compound interest. So the compound interest table is already available on the internet. You can download it because it's very helpful in finding the amount of value, the value of something, which is future value or present value. So you can skip this into quick formula. Now there are also another relationship, which is you want to know the present value if the future value is already mentioned or given. As always, FP is always come first because you want to know the present value, and then the future value is mentioned in this case. So the compound factor just repeat two alphabet that come first. After that, it's like PFBFIN, and the PFIN is already written in the compound table. And the other name of the FB is a single payment compound amount factor, and for PF relationship is single payment present worth factor. That's the other name of the compound method. And to illustrate the FB or PF, because FBPF is a single payment, it means that only single payment occur during the investment or during the debt, or during some loan period. So let's say I investing something, I pay something. Let's say I purchase a machine, and I want to know the remaining life in the future, the remaining life, the remaining useful life, the remaining value after a certain period. Let's say F. So I want to know the future value if I know the price of the machines. Okay, now let's take a look another example. A retirement deposit 150 million in a saving account that pays 20% interest. So how much he's saving after year 5? So the problem is that the principal value is 150, which is his retirement fund, and then the APR or the annual percentage rate, we can say that is it already in annuity, because annuity will fall between 6% or above, but below 6% we can assume that it's in the monthly system. So you have to convert it into annually. Let's say the 20% is the annual percentage rate, which is APR. We can summarize it as APR. The number of period is 5. So the question is, how many his investment after he deposit all this retirement funding to a certain organization or to a commercial bank or insurance. So the latter, which is the latter investment, the amount of latter investment will be called as future value, right? So it is just like the relationship between the present and also the future value. The present system, the present amount is already mentioned in this case, which is 150, and located in a 0 period, which is the beginning of time we investing something, or the beginning of time we borrow a money, or we have to pay money or something like that. Yeah. And the interest rate charged 20%. And how about the future value about this case? So let's take a look here, your compound interest factor. To read the table, you just find out the appropriate APR, or the percentage rate of interest. In this case, the APR is 20%. Just find out the right amount of APR. Now I have my own, which is 20%. Now look carefully that is it in a single payment? So you have to read carefully what kind of type compound interest factor, since in the single payment and you want to know the future value, so you just look the compound factor which is suitable with this case. Find future value if the present value is already mentioned in this case. So, and then to find out the right amount of the compound interest factor, just take a look the number period. and represent the number. Since the investment takes 5 years, so just find the end of 5 and then move to its what is it? It's right. Yeah. Let's take a look at the right position, which is 2.488. 2.488 represent the compound interest factor, which is single payment, and just fill the bracket. Just fill the bracket since we already get by the compound interest table 2.5 something and times the principal amount 150 million. So his future value will be 373 million rupiah. Now let's take a look at another practice problem. So a student wants to gain an earning 4 years later up to 30 million. So in this case, she predicts, let's say she's a woman, this is a girl. She predicts that 4 years later, she has to collect 30 million because she wants to enroll the postgraduate programs. And then how much investment that should be deposited at the beginning of time? Let's say the APR is 50%. So the argument is just like the relationship between the future and also the present, right? So the future value is 30 million. The APR is 50% per year. It's already in an annual, so we don't convert it into monthly basis. And represent the year. Let's draw the cash flow first because it helps you to understand the situations. Okay, so let's draw the 4-year period. And at the end of year 4, we know that she must earn 30 million. 30 million. And she wants to know how much money that should be invested at the beginning of time. Just do the same action, just the same activity as the previous one. Just look carefully the right or the correct APR that located in the left or the right in your page, and then find out the single payment because we consider the situation as a single payment. Yeah, a single cash flow, just like a single cash flow. Now, let's find out the right number, which is the right period 4, and then look carefully the right column, which represent find present value when your future value is already given 2.5 something, and then just fill in the bracket, and then just time it into principal amount. So we can get that the initial amount that should be invested by her is 70 million something. Okay, so that's the beginning. So that's the beginning of time of money, the introduction time of money. In the next video, I will tell you about the other compound factor that apply in many countries and many organizations.